Alright, here comes part 3 of the editor series. Just open up the same folder, and inside there you'll find 4 files that we will be looking at: chassis, engine, garage, and wheel. Changing these files will not introduce any change in the physics. These files are for you to take a look and familiarize what the physics already are. These are kind of like a reference tables. Before you study those and memorize them, in a way, you cannot go any farther into editing because you wouldn't even know what to edit to begin with. But at least the engine part of it, that's where we're gonna start with. I already have it opened and colored just like last time. COP is blue, GNS is orange, CTS is yellow, and PTA is purple. We went through the chassis section last time. This is field number 2. And for those of you that noticed the unused engine number 6 right here and unused engine number 1, these are really not used. I could not find them anywhere. I could not find a chassis that implements these engines, so messing with them or even looking at them will not make any difference. So we're just gonna grade them out. Now let's take a look at the most used engines in the series, and those would be engine number 2 for COP, engine number 7 for GNS, engine number 12 for trucks, and engine 15 for PTA. Besides restricted plate engines, these would be the 4 engines that the physics use. And CTS and PTA do not even use restrictor plate, so these are the engines that they use, the one and only, besides the qualifying ones. So let me try to copy paste them next to each other a little lower. There it goes. Now we could see the differences between the engines that are used in 4 different NASCAR series. Let me real quick copy paste the definitions. There you go. Here we got our let's go from the bottom up. The transmission part ends right here with the gears, and it's completely separate from your engine profile. Oil cooling and water cooling, well, pretty much. I'm not sure what the numbers exactly are, but I'm assuming the bigger number the better when compared to the engine that chassis 0 uses. We'll do that probably in the next video just to save a little time. But oil cooling and water cooling, pretty much the same thing for all 4. These 2 fields, I really don't know what they are, but they're all the same all throughout all engines, and there's really no definition for those. Now here comes the interesting part, is the actual engine profile. Besides the chassis that it belongs to, there we go. So we got RPM 1, RPM 2, and RPM 3. This is pretty much 3 reference points for your engine power production. What else to say? RPM 3, all NASCAR engines are 9,000 right there, while the rest of the torque is distributed a little bit differently between the 3 of them on RPM 2. Also, COP engine makes the most torque out of all of them. Well, that is expected. Okay, now let's go a little lower. This fields right here, this is your engine size and your intake size. This is like your internal parts of the engine dimensions. Let me paste them right there real quick. I'm not sure exactly how they are programmed into the game, but this is pretty much the dimensions. If you're out to measure like length and distance of your engine parts, these would be the main ones. The rest of them is pretty much the numbers of how much torque and horsepower the engine of whatever size you got makes, if you ought to split it into 2 different parts. Okay, so the torque part would be right here. The actual engine sizes and dimensions would be right here. And the rest two lines that we gotta have to deal with is red line, which is maximum RPM, and peak horsepower. I'm not sure when the engine makes the top horsepower. Does it make it at 9,000? Does it make it at 7,000 when it makes most of the torque? Or does it make 815 at red line? I know from real life that it would be a little bit less than the red line when it makes peak horsepower. But however, these are the values that we're dealing with. This would be 1, 2, 3. This the most simple parts of the engine profile that are going to make a difference. Do not mess with the cooling for now. Do not mess with gears or anything like that, just not yet. Torque, there's a extra video that I'm gonna make regarding torque 1, torque 2 and torque 3, because these are not real values. Like, these are too small to be real life torque values, so I'm assuming these are some type of game calculation values that are used right here. We're just gonna talk about them a little later. For now, I just want to cover the engine size part of it. If the video is not too long already, I'm gonna copy paste the engine number 0 right here. I mean, yeah, it's engine number 0 and it goes in the chassis number 0. That's fine. It is what it is. 450 big block. Let me copy paste the engine dimensions of this big boy right next to what we got. And here we are. We got bigger stroke, bigger cylinder diameter, I mean cylinder displacement, same V8 with one valve per head, bigger valves. So this is complete chassis 0. Why is it so special? It has completely different engine in it, not just 450, but everything else, the internal pistons and all of that is also different. Now I have some example pictures for you to see what those values actually are. Cylinder stroke is, let's say you have 8 cylinders. Right here we have 2 cylinders, and your piston is going to have a motion up and down or side to side depending on how your engine is set up, but this is pretty much what it is. Stroke is the distance that the piston travels from top to bottom when the air enters the engine through the valves, through the intake valves. Bigger stroke, meaning you can suck more air, or actually you have bigger area to suck the air into to make that horsepower when the spark ignites. Next one is the cylinder displacement. It's in cubic inches, and right there you could see the green value right here. That's what I was just talking about. That's the area of how much volume you could fit in one of your cylinders. Depending on how low the cylinder goes, the bigger volume you could fit into the engine, as we could see right here on engine number 0. Number of cylinders, well, that is self-explanatory. That's 8 cylinders, American V8 racing. Number of intake valves. Right here is 2 different cylinder heads. This is the one that is similar to the NASCAR head that is used. It has 1 intake valve and 1 exhaust valve per cylinder. There's 4 cylinders on this head. For example, if you want to edit that line and have a more modern, or let's say Japanese oriented engines, because most of them have 4 valves per cylinder, you would change this number to 2 and have 2 intake valves per cylinder. As you can see on this head, 1, 2. Side view of the valves would look like this, and the cylinder diameter, valve diameter, would be the distance from here to here. The bigger the valve, the more air you could squeeze in into the volume that you have right here. This is how the game is programmed. This is from real life values. This is all the information, most of the information that you need to make a complicated formula for calculating engine horsepower and torque. This is pretty awesome with what they've done. Red line, peak horsepower, self-explanatory. Then oil and coolant, I believe the bigger the number, the better. Because if we look at our 450, it has magic values right here. Oil coolant is nearly doubled, and water coolant is about maybe 60-50%. I'm not gonna make that calculation, but these values are drastically increased compared to the 358 engine. Here we go. This is probably the end of part 3. I'm gonna go in more detail once again to make it a little bit more self-explanatory, and you'll be more familiar with what I'm talking about once we go in farther into the editing process. But for now, I'm just gonna cut it right here. And if you have any questions, please let me know. I'm gonna try to go slowly in more detail, more into what you want to edit in this profile to get the changes that you want to have. For now, I believe this will be it. Hopefully it was educational and not too boring.